Hi. In class today, we spent a good deal of time talking about square roots, or more generally, radical expressions. And I tried to ask students to think about the difference between approximating answers and simplifying answers. So the problems that I'm going to go over in this short video have to do with simplifying answers, and they come from page 264 in the Advanced Algebra book. And I won't be explaining everything step by step, but I do want you to get a general feeling for what's going on. So for instance, if asked to simplify the expression the square root of 56, I choose factors of 7 and 8. And I'm not choosing these at random. I'm looking to ultimately find factors that are square factors. And you'll notice that the number 4 is a square factor. The square root of 4 turns into the number 2, and underneath the radical sign, that leaves me with the product of 7 and 2, which is 14. There are no square factors inside of 14. So 2 root 14 is exactly the same as root 56, except this is considered to be simplified. Let's look at number 2, which has a radical of root 80. In this case, I could have chosen 8 and 10, 2 and 40, all kinds of factors. I chose, and this isn't the only right selection, but it's the one that I decide to work with, the root of 5 times 16. Why did I choose 16? Because it's a square number. The square root of 16 is 4, which leaves me with a 5 under the radical sign. Let's take a look at one that involves a fraction, and you'll see that in math I have the ability to break up this fraction into a separate numerator and denominator. After this step, the steps that I'm executing are the same as the ones in the previous problems, where I'm looking for square factors. And so I end up with 4 root 3 over 7. Same idea in number 4. And of course, because you're watching this video, you can always pause. You can try out the next problem before I reveal it. Use it to your advantage. But you'll notice that in 4, I'm basically following the same thought process that I did in number 3. I'm going to kind of do these last two problems because I think they're valuable. Today we learned that back in the 1600s, Descartes was frustrated at not knowing what the square root of -1 was, so he defined the square root of -1 to be the imaginary unit I. So